Hi everyone! Today we're talking about solving linear equations, and this is basically what we've been working on in class for the past few days, and I want to make sure that you have some nice hardcore notes in your notebook ready to go. So you do have a foldable, so be sure that you print that out and you paste it in your notebook. Basically what you're going to do is print it out, fold it in half the long way like a hot dog, and paste it into your notebook so that the tabs that say solving two-step equations, combining like terms, solving equations with grouping symbols are facing up or facing outwards in your notebook, and you're going to cut along those horizontal lines to make separate windows. And then you can go ahead and take your notes within that foldable. So the first column of notes that I'm going to work on today is going to kind of be off to the side, right? So when you think about opening up that foldable and seeing it, what we're going to do is write these notes on the inside flap of the foldable. So kind of like I took that title that says solving two-step equations, I opened it up, and on the back side of that is where I'm going to take the first set of my notes. So these notes in particular are talking about how to do certain steps. Next to those notes is going to be a column for you to write an actual example. So you're kind of writing on the inside of the flap and then across from it to have an accurate example of what we're working on. So I'm going to write in some lines so that I can follow what we're talking about. So the first third, I guess, of the foldable is going to be the solving two-step equations tab. And we're going to do this by working through an example. So the example that we're going to do is 3y plus 6 equals 15. And the first thing we're going to do is we're going to undo the addition or subtraction. So typically we think about combining like terms, but there aren't any like terms in this particular example. So first of all, we're going to undo addition and subtraction. And we do this with our inverse operations, so don't forget that this is what we were talking about when we were talking about an inverse. So the addition that I see is plus 6, so I'm going to use the inverse, which is minus 6, and I need to do that on both sides of my equation. So when I have 6 minus 6, it equals a 0. 15 minus 6 is going to equal 9. So what I have left here is 3y equals 9. Now I'm going to do the second step of solving an equation, which is to undo the multiplication or division in a problem. Again, this is the inverse operation that we're thinking about. So in my example, I have 3 times y equals 9. So I need to do the inverse, which is to divide by 3. Again, we do that on both sides. 3 divided by 3 is equal to 1. So that's my identity. So what that really means is it's just 1y is y. 9 divided by 3 is 3. Now I have a variable equal to one whole number, and I'm all set. The last step that you always want to consider is to check your solution. And that's to plug in your value. And the way to do that is to take the variable that you have, which is in this case y, and replace it in the equation with the number that you found. So instead of saying 3y, I'm going to say 3 times 3 plus 6 equals 15. And I want to make sure this is true. So 3 times 3 is 9, plus 6 is, in fact, 15. So I know that the value that I saw for y is actually true. The next component of our notes is going to be the CLT, which is to combine like terms. And we're just going to remind ourselves how we combine like terms in different sides of the equal sign. So this example says 3n plus 9 plus 4n equals 2. So the first thing I'm going to do is combine the like terms on each side of the equal sign. So what I mean by that is to take all the like terms on the right of the equal sign and combine them, and then take all the like terms on the left side of the equal sign. So when I look at my problem, I see 2 like terms on the left of my equal sign. That's my 3n and my 4n. And I have to remember to keep the sign that is in front of my term. If there's no sign, we assume that is positive. So when I combine the terms positive 3n plus positive 4n, I'm getting positive 7n. Then I rewrite the equation just the way I normally would. Plus 9 equals 2. Your second step is going to be to, again, use your inverse operations. So inverse for addition and subtraction, and then your third step, inverse for multiplication and division. Now to inverse plus 9, I'm going to subtract 9. 9 minus 9 is actually 0. So I'm going to start putting circles around my addition, subtraction, inverses to remind myself that it's actually a 0. Then I bring down the rest of my equation. 7n equals 2 minus 9 is negative 7. Now I'm going to do the inverse of 7n, or 7 times n, which is dividing by 7. And when I do this, I'm going to draw myself a 1 around that expression, because 7 divided by 7 is 1. So that gives me n equals, now this one's tricky, negative 7 divided by 7 is actually negative 1. So now I'm going to do my check. Once again, I'm going to plug the value for n into the original equation. 3n plus 9 plus 4n equals 2. 3 times negative 1 is negative 3, plus 9, plus 4 times negative 1 is negative 4. So negative 3 and negative 4 make a negative 7, so 9 minus 7 equals 2. I know that I'm correct, so I'm going to circle my answer. The very bottom third of our foldable is going to outline for us distributing and solving equations that have to do with grouping symbols. Grouping symbols are always your parentheses, your brackets, all those kinds of things, where you use symbols to keep a group of numbers or operations together. So the example we're going to use for this is 2 times the quantity b plus 4 equals 12. The first thing we always want to do when we're working with grouping symbols is to distribute if necessary. We've practiced this before, but not in combination of solving equations. So first we're going to distribute to clear out our parentheses. So I'm going to distribute my 2 to the b and to the 4. So I get 2 times b plus 2 times 4 equals 12. And then I can solve that through. So 2b plus 8 equals 12. Now I kind of repeat the steps that I had before. Step number 2 should be CLT, combine like terms. I don't have any like terms in this particular example, but I would check and make sure that I don't. Step 3 would be inverse of addition and subtraction. Step 4 would be inverse of multiplication and division. So again, take a look. I see a plus 8, so I'll do the inverse operation, which is minus 8, which will leave me with 2b equals 4. And then I see a 2 times b, so I'm going to do the inverse operation, which is to divide by 2. So 2 divided by 2 is 1. I have b equals 4 divided by 2 is 2. And lastly, of course, as always, make sure you check by plugging in your variable. 2 goes back into my original equation. I'm going to do that over here to the side. 2 times 2 plus 4 equals 12. So I'll distribute. 2 times 2 is 4, plus 2 times 4 is 8, equals 12, which is correct. So I'm all set with that. There is no proof problem for your video tonight. I just want you to really be thoughtful about what you know, what you learned, how you're making progress in terms of solving linear expressions.